and more difficult because more abstract argument for the existence of God is the first cause argument. Before going into the difficult form of it, let's just look at the simple, basic, intuitive, natural, commonsensical form of it. I think we all have to become rather clever in order to doubt it or to dispute it, because it's based on an instinct of mind that we all share. The instinct that says everything needs an explanation. Nothing just is, without a reason why it is. Everything that exists has some adequate or sufficient reason why it exists. Philosophers call this the principle of sufficient reason. We use it every day, in common sense and in science, as well as in philosophy. If you saw a rabbit suddenly appear on this empty table, you would not blandly say, "Hi there, rabbit, you came from nowhere, didn't you?" No, you'd look for a cause. You would assume there has to be some cause. Did the rabbit fall from the ceiling? Was I a magician who had it up my sleeve? If there seems to be no physical cause, you would look then for a psychological cause. Perhaps there's no rabbit there. Perhaps you're being hypnotized or dreaming. As a last resort, you'd look for a supernatural cause, a miracle. God created the rabbit. But there must be some cause. We never deny the principle of sufficient reason itself. No one believes the pop theory, that things just pop into existence for no reason at all. Perhaps we will never find the cause, but there must be a cause for everything that comes into existence. Now, the entire universe is a vast interlocking chain of things that come into existence. Each of these things must therefore have a cause. My parents caused me, my grandparents caused them, etc. But it is not that simple. I would not be here without billions of causes, from the Big Bang through the cooling of the galaxies and the evolution of the protein molecule to the marriages of my ancestors. The universe is a vast and complex chain of causes. Now, does the universe as a whole have a cause? Is there a first cause, an uncaused cause, an eternal cause, a transcendent cause of the whole immanent chain of causes? If not, then there is an infinite regress of causes with no first link in the great cosmic chain. If so, then there is an eternal, necessary, independent, self-explanatory being with nothing above it, nothing before it, nothing supporting it. It would explain itself as well as everything else. For if it needed something else as its explanation, its reason, its cause, then it would not be the first and uncaused cause. Such a being could be called God. If we can prove there is such a first cause, we will have proved that there is some sort of God. Now, why must there be a first cause? Because if there isn't, then the whole universe is unexplained, and we have violated our principle of sufficient reason for everything. If there is no first cause, each particular thing in the universe is explained by some other thing, but the universe as a whole is not explained. Everyone and everything in the universe says in turn, "Don't look to me for the final explanation. I'm just an instrument. Something else caused me." But if that's all there is, beings that say that, then we have an endless buck-passing universe. God is the one who says the buck stops here. One more analogy. Suppose I tell you there is a book that explains everything you want explained. You want that book very much. You ask me whether I have it. I say, no, I have to get it from my wife. Does she have it? Well, no, she has to get it from a neighbor. Does he have it? No, he has to get it from his teacher, who has to get it from, etc., ad infinitum. No one actually has the book. In that case, you will never get it. However long or short the chain of book borrowers may be, you will get the book only if someone actually has it and does not have to borrow it. Well, existence is like that book. Existence is handed down the chain of causes, from cause to effect. If there is no first cause, no being who is eternal and self-sufficient, no being who has existence by his own nature and does not have to borrow it from something else, then the gift of existence can never be passed down the chain to others, and no one will ever get it. But we did get it. We exist. We got the the gift of existence from our causes down the chain. And so did every actual being in the universe, from atoms to archangels. Therefore, there must be a first cause of existence, a God. St. Thomas Aquinas has a number of versions of this basic argument. I think the most interesting is the third way. He argues that if there were no eternal, necessary, and immortal being, if everything had a possibility of being or not being, and thus a possibility of ceasing to be, then eventually this possibility of ceasing to be would be realized for everything. If everything could die, then given infinite time, everything would eventually die. But in that case, nothing could start up again. We would have universal death. For a being that has ceased to exist cannot cause itself or anything else to begin to exist again. And if there is no God, then there must have been infinite time. The universe must have always been here, with no beginning and no first cause. But this universal death has not happened. Things do exist. Therefore, there must be a necessary being that cannot not be, cannot possibly cease to be. Another description of God. How can anyone get out of the tight logic of this argument? Well, here are 4 ways in which philosophers try. First, many say that the proofs don't prove God at all, but only some vague first cause or other. The God of Abraham, the God of Isaac, and the God of Jacob is not the God of philosophers and scholars, writes Pascal, who was a passionate Christian but did not think you could prove God's existence logically. Well, it's true that the proofs do not by any means prove everything the Christian means by God. But they do prove a transcendent, eternal, uncaused, immortal, self-existing, independent, all-perfect being. That sounds rather like God. It's a pretty thick slice of him anyway. Second objection is that some philosophers, like David Hume, say that the concept of cause is ambiguous and not applicable beyond the physical universe to God. How dare we use the same term for what clouds do to rain, what parents do to children, what authors do to books, and what God does to the universe? The answer is that the concept of cause is analogical. That is, it differs somewhat, but not completely, from one example to another. Human fatherhood is a bit like divine fatherhood, and physical causality is a bit like divine causality, but also unlike. The way an author conceives a book in his mind is not exactly the same way as a woman conceives a baby in her body either, but we call both causes. In fact, we even call both conceptions. The objection is right to point out that we do not fully understand how God causes the universe, as we do understand how parents cause children or clouds cause rain. But the term remains meaningful. A cause is the sine qua non for an effect. If no cause, no effect. If no first cause, no second causes. If no creator, no creation. If no God, no universe. Third, it is sometimes argued, as Bertrand Russell does, that there is a self-contradiction in the first cause argument. For one of the premises is that everything needs a cause, but the conclusion is that there is something, God, which does not need a cause. The child who asks, "Who made God?" is really thinking of this objection. The answer is very simple. The argument does not use the premise that everything needs a cause. Everything that comes to be needs a cause. Everything that is born needs a cause. Everything that changes needs the cause. Everything dependent needs a cause. Finally, it is often asked why there can't be infinite regress with no first being. Infinite regress is perfectly acceptable in mathematics. Negative numbers go on to infinity just as positive numbers do. So why can't time be like the number series with no highest number, either negatively, no first in the past, or positively, no last in the future? The answer is that real beings are not like numbers. They need causes. For the chain of real beings moves in one direction only, from past to future. And things in the future are caused by things in the past. But positive numbers are not caused by negative numbers. Actually, there is a parallel in the number series for a first cause, the number 1. If there were no first positive integer, no unit 1, there could be no subsequent addition of units. 2 is 2 ones, 3 is 3 ones, and so on. If there were no first, there could be no second or third. If the argument is getting too tricky, the thing to do is to return to what is sure and clear, the intuitive point I began with. Not everyone can understand all the abstract details of the first cause argument, but everyone can understand its basic point. C.S. Lewis puts it this way: I felt in my bones that this universe does not explain itself.
Richard Dawkins, who is perhaps the most famous atheist on the planet today, he will say, if you, Frank, say God exists, then you have a problem because you have to answer an attendant question, and that attendant question is, who made God?
Oh, yeah, you get that question all the time. Well, the answer to the who made God question is nobody, because nobody made God. God is the uncaused first cause. He is what Aristotle would call the unmoved mover. And this isn't special pleading on our part. We're not just saying, well, we don't need a cause, but the universe needs a cause, or God doesn't need a cause, but the universe needs a cause. We're saying the evidence points to the fact that the universe had a beginning. There's only two possibilities. Either the universe is the uncaused first cause, or something outside the universe is the uncaused first cause. All the evidence shows that the universe had a beginning. If the universe had a beginning, if space, matter, and time had a beginning, then the cause can't be made of space, matter, and time. In other words, the cause must be spaceless, timeless, and immaterial. Now, if you're timeless, do you have a beginning? No, God is the uncaused first cause. It's interesting too, Hank, that for many centuries, atheists had no problem believing in an eternal universe. They thought the universe was eternal. Never had a problem questioning that. Now we come along and say, no. There's something eternal, but it's not the universe, it's God. And they go, oh, you can't have an eternal God. Well, wait a minute. If you can have an eternal universe, why can't there be an eternal God? Especially if this being's outside of time. He didn't have a beginning, he created time.
And you only really have, people think that there are thousands of possibilities for the beginning of the universe, but actually there are only a few, and only one makes sense. In the beginning, God created the heavens and the earth.
Exactly. And I like what my friend John Lennox says. He says, look, there's two ultimate worldviews at the end of the day. Either matter gave rise to mind, or mind gave rise to matter. That's it. When you get down to it, you boil them all down. And we know that matter's not eternal. Matter had a beginning. If matter had a beginning, it can't be the first cause. Mind is the first cause. And that comports well with, of course, John, the first chapter, that in the beginning was the Word, the mind, the logos, the reason. That's really where the universe came from. It came from a mind and is sustained as we speak by a mind.
One of our recurring themes has been the origin of cosmos, right? In the last 100 years, scientists, philosophers, theologians all agree that indeed the universe had a beginning. And when we jump to the law of causation, specifically the Kalam argument, it is that anything that has a beginning has a cause. And therefore, since the universe had a beginning, we would argue that the universe had a cause. Now, the theist immediately jumps to Creator God. Indeed, this is proof for a creator. The naturalist materialist will jump in and cry foul, because then they'll say, based on the same argument, the same logic, who created your creator? I'll go to A Letter to a Christian Nation by Sam Harris, and this is how he puts it. As many critics of religion have pointed out, the notion of a creator poses an immediate problem of infinite regress. If God created the universe, who created God? To say that God, by definition, is uncreated simply begs the question. You see where he's going there? He's saying that if you're going to use the law of causation to declare creator God, then who created God? And it's an infinite regress backwards to who created that creator, to who created that creator, etc. What I would do is I would take it one step back in logic, in reason. I go to Thomas Aquinas here. Now, Thomas Aquinas, who's not mentioned in Sam Harris's book, he basically appeals to two principles in scientific reasoning, and that is that every effect requires a cause, and nothing in the world is the cause of its own existence. Do you see where I'm going there? The notion is if there's an A, there must have had to have been a B that brought A about. And if there's a B, there must have been a C that brought B about. And that goes on and on and on backwards. But at one point, I have to have an uncaused cause, or there would be nothing in existence today. If there was no B that came before A, there would be no A. And if there was no C that came before B, there would be no B. And if you take that all the way backwards, there had to have been an uncaused cause. Think of a string of dominoes. You have a domino that knocks over a domino that knocks over a domino. I have to have a first domino, or that string of falling could never start. Do you see where I'm going? By logic, by scientific reasoning, by mathematical certainty, I had to have had an uncaused cause in the very beginning. Now, that cause is God for Thomas Aquinas. That uncaused cause for the naturalist materialist is a singularity, an infinitely dense vacuum fluctuation in the metaphysical realm before all of this began. Do you see where I'm going? Nobody agrees that there is an infinite regress. Everybody agrees that there had to have been an initial starter, an initial cause. I just refer to that uncaused cause as God. And the naturalist, materialist, atheist refers to that uncaused cause as a singularity existing outside space and time in the beginning.
First cause is an ancient argument for God's existence. It explains that everything in the world is the product of a cause-effect relationship. Everything is caused by something else prior to it. I am here as a result of many causes, which include the union of my parents. Their existence is also caused by a series of causes. If we chase things back in time, St. Thomas Aquinas argued that God must exist because he is the first cause of the whole created universe. Over the last century, discovery of the Big Bang has provided scientific evidence for the beginning of our universe. But what caused this beginning, of which even Genesis speaks? What must be true of this first cause for it to have created the universe? Dr. Peter Kreeft defines the first cause as an eternal, independent, self-explanatory being with nothing above it, before it, or supporting it. It would have to explain itself as well as everything else, for if it needed something else as its explanation, then it wouldn't be the first cause. In effect, the first cause must be beyond everything it causes. Our universe includes matter which is tied to space, as matter takes up space. No matter, no space. Space, as Einstein proved, is tied to time. Energy is also tied to matter, space, and time. So for the first cause to cause the universe and chain of events that followed, it must be outside of matter, space, time, and energy. A couple of authors summarize first cause like this. That power must be infinite to create something out of absolutely nothing. The gap between nothing and something, between non-being and actual existence, is infinite. It takes an infinite power to bridge that infinite gap. Only God has infinite power, therefore God must exist. Since matter, space, time, and energy are all related, if these had a beginning, as the Big Bang proves, the first cause argument is back stronger than ever. A perfectly logical and now scientifically supported idea for the first cause is the Christian concept of God, though the data does not prove all that Christians believe about God. Nicholas Copernicus, naturalist and astronomer, once wrote, "Who could fail to be led by observation and thoughtful familiarity with the magnificent order of the cosmic system, which is derived from divine wisdom, to marvel at the Almighty Architect?"
Today, I'm doing an experiment that demonstrates Heisenberg's uncertainty principle. So here I have a green laser, and I'm firing it down towards the front of the room through a narrow slit. Now that slit can be adjusted so it could be made narrower or wider. And the laser spot is projected onto a screen behind it. So what do you think is going to happen to this spot on the screen as I narrow the slit? Well, let's have a look. You see exactly what you'd expect. The spot gets narrower and narrower. The sides are getting cut off by the slit. Makes complete sense. And if you stop there, you would never realize that Heisenberg's uncertainty principle is at work. But if you keep going, something strange happens. As you make the slit even narrower, the spot starts to spread out. Isn't that incredible? You're making the slit narrower, and yet the spot on the wall is getting wider. The narrower you make it, the wider that spot on the wall becomes. To understand this, we have to look at Heisenberg's uncertainty principle. Heisenberg's uncertainty principle is normally written as delta x delta p is greater than or equal to h on 4 pi. So what does this mean? Well, it's about the position and the momentum of a particle. So x is the position of the particle and p is its momentum. So delta x is the uncertainty in position and delta p is the uncertainty in the momentum. Now, if you multiply those two quantities together, they must always be greater than or equal to h on 4 pi. Now, h is Planck's constant, and that deserves a video all to itself, like this one by 60 symbols. But for our purposes, it's just a very small number. So in our everyday lives, we don't come up against this uncertainty relation because everything is much, much bigger than h. But as we narrowed the slit, we were decreasing delta x for those photons. So we were getting more and more precise about where the photons were passing through that slit. And at a certain point, you come to this limit, so that if you narrow this any further, you're going to break this uncertainty relationship. So what needs to happen is the uncertainty in momentum needs to go up. I should specify this is uncertainty in momentum in the x direction, in the horizontal direction. So if before photons were going perfectly straight, now they must veer off to the left or to the right to ensure that we don't break Heisenberg's uncertainty relation. And the more you decrease your uncertainty in position, the more narrow you make that slit, the more the uncertainty in momentum has to go up. And so if these photons are going to the left and the right, that's going to produce a much wider beam. It's really, really non-intuitive, but it's the way the world works.
Now, it was realized that a physical description of the universe prior to the Planck time, that is 10 to the negative 43 second after the Big Bang singularity, would require the introduction of quantum physics in addition to general relativity. On the quantum level, so-called virtual particles are thought to arise due to fluctuations in the energy locked up in the vacuum. Particles which the Heisenberg indeterminacy principle allows to exist for a fleeting moment before dissolving back into the vacuum. In 1973, Edward Tryon speculated whether the universe might not be a long-lived virtual particle whose total energy is zero, born out of the primordial vacuum. This seemingly bizarre speculation gave rise to a new generation of cosmogonic theories, which we may call vacuum fluctuation models. These models were closely related to an adjustment to the standard model known as inflation. In an attempt to explain, or explain away, depending on one's viewpoint, the astonishing large-scale homogeneity and isotropy of the universe, certain theorists proposed that between 10 to the negative 35 and 10 to the negative 33 second after the Big Bang singularity, the universe underwent a phase of super rapid or inflationary expansion, which served to push the inhomogeneities out beyond our event horizon. Prior to the inflationary era, the universe was merely empty space, or a vacuum. And the material universe was born when the vacuum energy was converted into matter via a quantum mechanical phase transition. Now, in most inflationary models, as one extrapolates backward in time, beyond the Planck time, the universe continues to shrink down toward the initial singularity. But in vacuum fluctuation models, it is hypothesized that prior to inflation, the universe as a whole was not, in fact, expanding. Rather, the universe as a whole is a primordial vacuum which exists eternally in a steady state. And throughout this vacuum, subatomic fluctuations occur by means of which matter is created and many universes are born. Our expanding universe is just one of these many universes, an indefinite number of which are conceived in the womb of this greater mother universe as a whole. And thus the beginning of our universe does not represent an absolute beginning, but merely a change in the eternal, uncaused universe as a whole. Though still bandied about in the popular press, vacuum fluctuation models did not outlive the decade of the 1980s. Not only were there theoretical problems with the production mechanisms of matter, but these models faced a deep internal incoherence. According to such models, it is impossible to specify precisely when and where a fluctuation will occur in the primordial vacuum, which will then grow into a universe. Within any finite interval of time, there is a positive probability of such a fluctuation occurring at any point in space. Thus, given infinite past time, universes will be eventually spawned at every point in the primordial vacuum. And as they expand, they will begin to collide with one another and coalesce with one another. Thus, given infinite past time, we should now be observing an infinitely old universe, not a relatively young one. Isham, who is probably Britain's leading quantum cosmologist, has called this problem, and I quote, fairly lethal to vacuum fluctuation models, and says that therefore they did not find wide acceptance. About the only way to avert the problem would be to postulate an expansion of the primordial vacuum itself. But then we're right back to the absolute origin implied by the standard model. According to Isham, these models were therefore jettisoned 20 years ago, and he says nothing much has been done with them since.
We've never observed something come from nothing. Now think about this. The universe is something. This world we live in is something. You and I are something. Now, science shows that this universe is finite. What that means is it had a beginning and it's going to have an end. So if something has never been observed coming from nothing, that means the universe came from something, right? However, this led to a very big conundrum in logic. If the universe is finite and had a beginning, and we've never observed something come from nothing, then that means that the universe came from some other source. And this was a conclusion that some just couldn't deal with. Think about it. If there was ever a time when there was nothing, there would still be nothing. So scientists have to explain why there is something instead of nothing, right? But then someone responded and said, wait a minute, we have observed at least one thing come from nothing. No, it wasn't something as complex as a dog, but it was virtual photons in what's known as the famous Casimir effect or Casimir experiment.
System of the famous Casimir effect, which was predicted by Casimir in 1948. Surprisingly, two conducting uncharged parallel plates attract each other in a vacuum. The reason is that there are always virtual photons. Photons are particles of light. There are virtual photons that come into and out of existence, even though no real photons may be present. Virtual photons cannot be directly observed, but they have consequences that can be observed. Because photons carry momentum, and because there are fewer photons between the plates, there's an imbalance of light pressure, which produces an attractive force on the plates. This force is extremely small and was not accurately confirmed until a half a century after its prediction.
So here's what the argument is basically saying in a nutshell. We can at least say that it's possible that the universe sprang from nothing because we've observed at least one thing spring from nothing, virtual photons in the Casimir experiment. But before you go trusting in quantum fluctuations to save the day, there's a couple of things about these virtual photons I'd like you to consider. These virtual particles are governed by the Heisenberg uncertainty principle. That's just a fancy name for a simple law that basically says, in part, that a short-lived state cannot have a well-defined energy. And that just means that the law places a limit on the amount of time that a quantum fluctuation can exist. You see, the greater the energy of the fluctuation, the shorter lived the intervals of that fluctuation. Now, one would expect that the energy content of the entire universe to be quite enormous. So that would mean that hypothetically, if the universe were in fact the result of a quantum fluctuation, that energy content would prevent it from existing for more than an incredibly small amount of time. Any newly born universe from a quantum fluctuation would virtually instantaneously vanish. Now, this makes it very difficult to imagine how our current immense universe could be the result of such a fluctuation.
As it nears the supermassive black hole at our galaxy's heart, the probe is at the mercy of one of the most fundamental forces in the universe. A force with the power to twist space and send the probe traveling through time.
Gravity is something incredibly commonplace. We're always dropping things, we're not flying off the surface of the Earth. It's a part of our lives from the moment that we're born. But it turns out it's a very mysterious and deep part of the universe. When something has mass, it has the ability to bend space.
Before Einstein's theory of general relativity, scientists imagined space as a stage set on which the action played out. Einstein's genius was to realize that space itself was an actor in the drama.
We tend to think of space as just the stuff around us, but it's actually kind of a thing. It has a physical component to it, like a fabric, like a sheet.
In empty space, light travels in a straight line. But place something massive, like our sun, on the fabric of space, and its immense gravity warps space. As light travels past the sun, its straight path curves.
So light bends, not because the light bends, but the space in which the light is traveling curves itself.
This is why our probe's trajectory is curving. The black hole's gravity is warping the fabric of space. Everything that travels through this curved space must follow a curved path, including light.
The amazing thing is that not only does gravity warp the light into the black hole, light coming from farther away gets bent around it. And so you could see this shimmering distortion in the stars in the background as a black hole moved in front. It would almost be like taking a piece of glass and moving it across the star field.
And it's not just space that the black hole is bending. Time is warping too.
So if we send a probe going into a black hole, from our point of view, we see it falling in, and we see it falling in more and more slowly because its clock is ticking slower and slower and slower. That's a bizarre concept, and it's really hard to wrap our brains around, but that is what the math and physics are telling us.
In this episode, I'm going to explain the mechanism behind how gravity works. Not that it works, not demonstrating its effects on stuff. I am actually going to show you the mechanism behind why two objects are attracted toward each other. I call it the Preissner gravitational hypothesis, named after my mother, of course. I hope I haven't set you up for a big disappointment, though. But here's my disclaimer. I am personally over 99% certain that I am right. However, I also recognize that the probability that I am right is less than 1%. So if you add those two numbers together, you get 100% reason to celebrate and make a YouTube video. So here's my pledge to you. If when it is shown that the PGH is mostly hot air and has very little substance. I will take full responsibility and make a video explaining what is so. To understand what causes gravity, I need to explain 3 natural phenomena. The first is the warping of space, and with that, time dilation, which together I simply refer to as space density, which in previous episodes I have talked quite a bit about. In denser space, all processes are slower. The second is the general behavior of quanta, that's very tiny things. Specifically, they act like waves and particles. Quanta can exhibit both wave and particle behavior. The third one is the properties of refraction. Simply put, it is like waves or particles diving into denser space. You may have experienced this yourself while driving down the road and you drove onto the shoulder. Because the gravel is not as smooth as the road, that side of the car moves more slowly and practically sucks the car off the road. Taking these ideas, let's apply them to a quantum orbit or oscillation. As the particle or wavehead progresses through each region of density change, the angle of refraction changes also. Combining the normal orbit with the forces of refraction, we get a new egg-shaped orbit. This model shows how that in the orbit in which the forces of refraction are at play, the entire system will shift toward the denser space. The orientation of the orbit in relation to the denser space is actually inconsequential. Here is where relativity helps explain the acceleration. Regardless of the initial velocity, every oscillation pulls or pushes the entire system into the denser space even more. A stationary observer would view them as accelerating. Of course, each atom would not feel that it was accelerating, it would just be going with the flow. So in short, every fluctuation of every quanta, every instant, and every movement moves toward denser space. This movement is what we call gravity. YouTube commentator Kevin Patterson asked how 2 resting bodies would move toward each other. Here we have 2 atoms that are at absolute zero, so there is no thermal energy to make them bounce off each other. Each atom distorts space around it. As the quantum vibrations, oscillations, and fluctuations interact with the space around them, they encounter slight differences. Since the space between them is denser than anywhere else, the sum of the refraction occurring brings them together. Together they double the density of space, which is exactly what is observed. When mass is doubled, gravity doubles.
In a magnetic field, the North Pole acts as the positive because it is attracting. In electricity, electrons flow from negative to positive. Gravity is also attracting. Therefore, gravity must be positive, the same as the positive pole on a battery that the electrons flow to, or the north pole of a magnetic field that the electrons, again in magnetic waves, flow to. It is not a negative energy. Let's take a look at why they need gravity to be a negative energy. Okay, they're trying to get the universe's total energy at zero. Here you can see the Earth's magnetic field flows from the South Pole to the North Pole. The attraction point is the North Pole. It attracts. It is the positive side of the magnet. Okay, electricity also flows from negative to positive. And it is another electro form of energy in our universe. Here you can see a circuit with a light bulb and a battery. You'll notice the negative side of the battery is on the bottom, positive is at the top. The electricity is pushed away from the negative side of the battery.
It's called an energy transfer. And that energy transfer goes all the way through, heats up the element in the bulb, and returns to the positive side of the battery. Again, the positive side is attracting the electrons, where the negative side is repelling it. Again, pointing to gravity, which is an attraction, as being positive. But they need gravity to be negative in order to balance out the energy in our universe. And the reason they have to balance out the energy in the universe and bring it down to zero is because of the hub, the limit that this places on a quantum fluctuation is the greater the energy of the quantum fluctuation, the shorter time it can last. So if you have a universe full of energy like ours, and you're going to claim that it was created by a quantum fluctuation, and it's still 13.8 billion years later, still expanding and growing, you have to show this quantum fluctuation has the possibility of remaining for this many years and many, many more. And to do that, you have to bring the quantum fluctuation into existence with zero energy. And that's why they need a zero energy universe. And that's why they, out of nowhere, claimed gravity as negative energy. Gravity is definitely positive, as it is an attraction. Things are attracted to it, just like the positive terminal of a battery and the positive pole of the Earth. Everything flows towards the positive. There's no reason to be calling it negative other than to try to create a universe from nothing. Because they claim if you have nothing, a quantum fluctuation can pop into existence. Well, that's not true because they still need space. But that's the long and short of it.